welcome to zdeciphers.org. My name is Cordelia Kataria and I am a 9-year-old computing explorer and problem solver. Today we're going to be solving a problem called BIO. It's British Informatics Olympiad problem from 2011, round 1, question 3. And the problem's name is Upside Down. So, the problem says that, my name is Cordelia Kataria and I am a 9-year-old computing explorer and problem solver. I don't know if I already said that. Yeah, I probably did. So the question is, an upside down number is an integer where the ith digit from the left plus the ith digit from the, it says right, I'll just adjust it a bit so you can see it. Right. So ith digit from the right is always, is always equal to 10. So, for example, 1357 is an upside down number since 1 plus 9 is 10, 3 and 7 is 10, and since 5 is both the third digit from the left and the right, 5 plus 5 equals 10. So yes, it's an upside down number. The first few upside down numbers in numerical order are 5, 19, 28, 37, then all the way up to 82, 91, 159, and it keeps going on and on and on. So we have to write a program to determine the nth upside down number in numerical order. The input will consist of a single integer n, where n is between 1 and 2 to the power of 31. You should output a single integer giving the nth upside down number. I think, 1 second, there we go. I'm going to go to the, So what the problem is basically, saying is that we have to find the nth upside down number, and an upside down number is a number which let's say 13579. So the leftmost and rightmost, that sums to 10. The ones after and before it sum to 10, and then it keeps going like that. So for the working out, let's go to 1 second. Okay, there we go. Right, so I think we need to so to find the nth number, then approach 1. One thing we could do is just keep generating. Keep generating larger palindromic palindromic numbers. So then until we reach n. Until we reach n. So basically just keep making more palindromic, no, not palindromic, I mean upside down numbers. Upside down. Keep upside down. Upside down. Until we reach n. So basically just keep making upside down numbers. And to do that, we could, I think we could use recursion. So just keep doing digits from 1 to 9, and at the end check if we can check if upside down. And we can and I think we can optimize it by optimization. We can optimize it by a way we can optimize it is just prune it. So basically just do up to NO2. So when do up to NO2 and wait, no, not. Actually, I don't think we can do that because unless we knew the length of it. Oops. So what I was thinking of is if we knew the length, we could just go up to that length, divide by 2, and then just do 10 minus every digit of that. But we don't know the length, so this can't do that. So the time complexity of this would be 9 to the power of the length, and wait, actually, so I think it might be order of n because we keep going up to n. Okay, so the actually we do n things, and the time complexity of each thing is actually I'm not sure about the time complexity. I think it's order of n. But that's not. But I don't think that would be very efficient, because n is between 1 and 2 to the power of 31. So 2 to the power of 31 will 2 to the power of 31. I think that's about. That's just you can't see my calculator. That's about 2 times 10 to the power of 9, which is just too big. So yes, we'll have to optimize it then. So an approach to I think we might be able to use dynamic programming.
What is the recursive function here?
It's 1 second. So let's just call it F, then I think we have to take in the not sure. I think we might have to do n, and then
What does f of n return?
it returns a I think it returns the answer. Not sure.
So what variables will it depend on? Like, let's say you have f of like what f of like what variables will you have to generate f of n? Like this should come from some f, right?
Not sure.
So we have done similar. Let's try approaching it like that again. So we have to make a n digit number, right?
Yeah.
Not n digit, like some m digit number where we already know the m by 2 digits. So if we have the m by 2 digits, then we can make the rest of the m by 2 digits, right?
Yeah.
Have the first half, the second half is easy to make. Also, just like a very trivial observation, if n is odd, sorry, n is odd, if the number of digits are odd, what will be the middle digit be?
So, I don't understand.
So if we want to make a m digit number,
Yeah.
And n is odd, so what will the middle digit be always?
Yeah, it would always be 5 because
Yeah, because the number from the left and the number from right should be same.
Yeah.
Not same, but like they should amount to 10.
Yeah.
So this is just one trivial observation that we should just speak out. So now, how do we know the number of digits in the number? So how many numbers are there? Like how many one-digit numbers are there with this? Who follow this property?
There's think just one. I think just 5.
Yeah, so it's one. How many two-digit numbers are there?
I guess there's. I say 2 is even, so they need to sum to 10. So 19, 28, 19, 28, 36, 45. Wait, actually I'm pretty sure they're all the multiples of 9. 54 and 63 and 72 and 81. That's 8.
It's 19, 28, 37. Not 81, it will be 82.
Oh yeah, because it sums to 10, not 9. Doing 9.
Yeah, so there are total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers.
Yeah.
What are 3 ones?
I couldn't hear you because your voice was breaking.
What about the 3-digit ones?
The middle digit has to be 5, so there's 159, 258, 357, 456, 654, 555, 456, 753, 852, and 951. That's also 10.
Yeah. What about 2-digit ones?
So 4-digit, I think. So there's 4 numbers. So 1, and then these two, they're some numbers out of 10, and then these two, they can be anything out of 10 numbers. So I guess it's 100.
Right. 1 to 9. So 9 options here, 9 options here. Hello?
Yeah, so it's 81. Yeah, so
Right. And similarly for 5-digit answer will be 81. Does that make sense?
yeah.
So can we tell what the nth number of these series would be?
I think the so I think the I think the I'm not sure. 1, 2.
Try thinking about it a little more. Let's say you have a n-digit number. How many options are for the first half?
There's I think 9 to the power of length of the first half.
Yeah. And the length of the first half is?
That's over 2.
Right. So for a generalized nth term, we can say that it is n to the power n divided by 2 floor of n divided by 2. Can we say it?
No, I'm not sure, because for the number for the when m is 2, it's supposed to be 10, but the calculation thing says that it's
Yeah. So logically this thing is fine, right? Like for, let's say 1, 2, 3, 4 digits and above, there should be 2, right? So 4 digits, 5, 7, all the digits above 4, there should be 2, right?
yeah.
So we can treat the first few digits as edge cases. Let's just assign these values. And then for the rest of the digits, we can generate the numbers.
Yeah.
279. Oh, what is 81 into 9? 729, sorry. That's one. Is that fine?
Yeah.
So now can you think of something here?
1 second. Going down. Right, so so we have to find. So we want to find m. We have n. So let's so I think it's just sum of it. So I just have to keep adding.
This will be 9 actually.
What will be?
So when I was writing the numbers down, I wrote 6 twice.
Right.
I wrote the numbers on the right?
What numbers on the right?
I wrote the 2-digit numbers on the right.
Yeah.
So I wrote 46 twice by chance. So actually it is like the nth square will actually be 9 by 2.
Right, so I guess this works for all n actually. So we want to find m and we have n. So we just find the sum of this up to when it reaches n. So yeah. So I think just keep adding these terms until reach n. So I think we can code it. Yes. Let's go and code it. Wait.
Yeah, so we can write the code to get the number of digits.
Yeah. And 1 second, I'm just going to. This number is to choose like 2011. Question 3. Okay, I'm just going to get that file up.
Can you switch your screen?
I'm not yet because I'm just. No, now I can. Yeah. Okay. So to do that, you just. 1 second. Just going to. So for I in. Like. So I equals 0. And m equals 0. While I is less than n, then m plus equals to 9 to the power of and m over 2. M plus equals 1, and that's I, not m. Okay. just print out M. Print, and this actually will find actually it will find it's now and N is in input. Wait, it's not to power off M over 2. That. Okay, so I'm going to do an input of, let's do 4. Output is 3. Wait, I meant need to do 81. 5. I don't think this is working.
Why?
I think for the input 4, it's supposed to be wait, actually it is supposed to be 3. Wait, no, I think it's supposed to be 2 because for number 2 it's 10. For the second term in the sequence is 10, I mean. So it's on to right.
So I think you should be doing M plus 1 first and then I plus M divided by 2.
Right.
Like 5 and zip line should be with.
Let's do an input 4, 2, and then 85. And 4, that's 1, 2, 3, 4, yeah, that works. Okay, so if we have the length, then we need the function to. Wait, I'm gonna switch back to the working out. Where is my mouse? There it is. Right. There we go. Okay, so okay, so I think if we have the length, then just do I think if we have the length, then we can do then that number 2 would be, I think, then that number divided by 2 would be 1 second. Right, so that number divided by 2 would be the thing we need to work out up. So we need to work out up to that. So that is it's
if we have found out like it has this many digits, so we can also reduce n also, right? Because you know that we have to find the nth digit of that length.
yeah, so
What are we doing exactly, Vartika?
we're finding the nth upside down number.
Yeah. So not only the nth upside down number. Now find nth upside down number of length m. Right?
Did you write something?
Yeah, isn't it getting updated?
Oh yeah, I can see it now. Right, so next to
Also in this, we only have to find the first half, like m by 2 digits. Yes, m by 2 will be needed.
yeah.
So let's try to draw a few examples. That way it might get a little more clear. Let's find the fifth answer. So we already know that it can't be a one-digit number, so we'll run from here. So we need to find the fourth upside down number. Now, how will you generate the fourth upside down number?
By and to do it by just keep just keep. I think we could do it by just keep on just keep generating them until we reach. So it generate the first one, then second, then third, then fourth.
But that's very slow.
Yeah.
So if n is equal to 4, what will be the digit in the, like, what will be the first digit?
Then it would be
It would just be 4, right?
I think.
Okay, the one observation that we have is that we don't have 10 digits, we only have 9 digits here to work with.
Yeah.
So, if we know that our first digit is 4, then we also know that our second digit is 6.
Yeah.
So, for 2 digits, we know that if we'll just place n on the first digit and second digit we'll already know, right?
Yeah.
Now let's try generating the 13th n upside down number. We can already reduce 1 from this because we know that it's not a one digit number. We can also reduce 9 from this because we know it's not a two digit number. So this becomes, so we have to find the third three digit upside down number. So n is equal to 3 and m is equal to 3. Is in the middle.
So I guess think we know we know what the first digit is going to be if we just do the number minus the sum of the sequence, then so and then so well now what the number is.
I didn't get you, Kapil.
So I think we just have to do the number minus the sum of the sequence, then we know what the we can just do n minus I to get the first digit.
What will the middle digit be? That is easy, right? It's n is odd, right? So middle digit will be 5.
Yeah. Yes.
And then you can just place 3 there and so.
So
Did this make sense?
Yeah.
Are you sure?
Yeah.
Okay. So let's try generating a 4 digit one then. That should be a little hard, right?
Yeah.
Number to be 4 digit, it should be 11, 21, 102, 110th. Let's try generating 110th number. First we can reduce 1, we can reduce 9, we can reduce 9. So we know that like it's a 4-digit number here. First. Is that right?
Yeah. I think. Yeah.
Yeah, so we have to generate 91st. Wait, something has to be wrong here, no? Okay, we can generate a little smaller one. So, 21, 52nd. Let's try generating 52nd one. So 51, 42, 33. So this will be 33. So now let us try to see which number comes 4 places to fill, right? And we only need to focus on these ones. So we just need to think about the 33rd number that can be made using 1 to 9 only. So does that sound familiar? Like we can do something like 33 mod 9 will come here, then you will do 33 divided by 9, and then that number will come here.
Yeah.
Like it is something like a binary, like that's how we make binary numbers, right?
Yeah. It's similar to that, except just 9 instead of 9 instead of 2, and also it's yeah, and also it's numbers, not letters. Wait, binary is numbers too. Yeah. So
Yeah, hex is when letters are all come. So yeah, here we can start implementing this, right?
yeah. So wait, where is my mouse? There is. So we have okay, I'll just keep it there. So so I think you ask equals to actually it starts at 9 to the power of it just start at 1 actually. While mask is less than n. Wait, less than in n equals n minus I.
What is mask here?
It's like what we. It's the thing we have to do, and Yes. So, for example, for the first digit for 33 mod 9, just do 33 minus the closest power to 9. So actually closest multiple. I meant the closest multiple. Actually, that won't work. Okay, so.
Okay, just a small thing. When on line 8, if you do n minus equal to I, then n actually becomes negative. So you need to add 9 to the power m by 2 to it.
9 to the power of m. 8. Okay, so and you and so it's let's first print out and mod 9. So you have to do wait, actually it's slide key 3. I think we just keep save while n is more than 1 and so print out and think and I don't know. So let's do 33. Right, so
You should print n mod 9.
So print that n mod 9. So 33. Okay, that's the 4 and then 5. 33 mod 9 equals to 33 divided by 9. That's equal to I think that's supposed to be a 6. 30.
That's supposed to be
6. I'm just going to check. Yeah, it's supposed to be 6. And that's what's 33 divided by 9. So that's supposed to be 6 and then 3.
what happened?
I think it's supposed to output 6 and then 3, but it did. Wait. But it did. Wait, actually, the input. Oops, I didn't do the right input. It's 52, not 33. Okay. I put 6 and 3. It works. Okay. So then let's just do one really complicated input. Right. Let's go to the mark scheme. Mark scheme, 1 second. Plus olympiad. Okay, 2011. Round 1. Marks. Okay, so for question 3, let's just take the biggest input there is. Run. 3. Okay, so 8, 8, 6, 7, 6, something. 8. Okay, that was not what the numbers were supposed to be. Let's take something a bit smaller. 1, 4, 8. Now this is supposed to be 1, 4, 1, 5, something. For some reason it's not working.
Try generating an answer for the first few numbers rather than such big numbers.
For what? Okay, so
Like go for 1, then 2, then 3, then 4, something like that. Okay, we haven't handled the n odd case here. Sorry, the m being odd here.
yeah. So yeah, I think that's why. Wait, but this one it was even, it still didn't work. Okay, let's do 1. Okay. 2 with 2. Yep. 3. 3 outputs 2. So is that the sad? Wait, let me.
Particularly, we haven't handled the m being 1. Sorry, m being odd here. We need to handle that first.
Okay, so then so if mod 2 is not 0, let's just say is 1, then if it is 0, then do that and that and that and arithmetic error. Okay.
Okay, if m is odd, then what are we doing then?
If n is odd, and if I think it's the same, but we also add a 5 on the end.
Okay. You also need to reduce m by 1, right, if we have printed 5.
Right. So m is equals 1 and print out 5. 12 something 2 and then 5. Right, is that
Okay, the wrong n is getting, like m will get reduced by 1 here. Like 14 and 15 line need to be switched.
Wait. Right there. So for 3, output's 2. For 2, output's 2. For 1, the output's 1 and 5. Wait. And so it's not supposed to print out that 1, it's supposed to be only 5. I think.
You have printed m on line 7, that's why.
Yeah. So 1, 5, 2 is nothing. 3, 2. That's it. Yeah, because I think for 2 it said that m equals 1, and so when we took away 1, then I guess that turned to 0. But so I think
Okay, these are all implementation specifics, I think, so we solve them offline.
okay, so where is my mouse gone?